Okay, I want to do a screencast that focuses on the stereochemical aspects of your final exam. One type of problem that you need to be comfortable doing is, given a Newman projection, as the one I have shown you right here, you need to determine relative stereochemistry, even name the compound. So what I'd like to do is show you how we can go through a problem like this, and you're going to need to use a little bit of creativity because it's going to ultimately depend on your ability to rotate bonds. So if I rotate this such that the front carbon will be to the right and the back carbon will be to the left, do a better job of that. So carbon 2, carbon 3. Now carbon 2 has a methyl group that will be in the plane. Carbon 3 has a methyl group that will be going into the plane. And carbon 2 has, actually I'm going to start this over. Let's go back. Carbon 2 in the plane has an OH. We have a methyl group that will be coming out. And of course we will have a hydrogen that will be going in. Carbon 3 has a bromine that's in the plane. And we have a methyl group that will be going in and a hydrogen that will be coming out. So we have translated a Newman projection to a terse structure, and I want to straighten this up just a little bit. And so now we can look at chiral centers. So let's look at this one first. We are going to have priority 1, priority 4, priority 2, priority 3. Going from 1 to 2 to 3 is going to be moving in the clockwise direction. So this will be R. And if we look at this carbon, we are going to have carbon, see, this is going to be priority 4, priority 1, priority 2, priority 3. We can go 1 to 2 to 3, but we'll need to flip our answer. So we're going we're going R, but we've got to flip it to S. And now in terms of naming, carbon 1, 2, 3, 4. So we're going to have butanol. If you like, you can go 1-butanol. Actually, can't go 1-butanol. I got to go 2-butanol. And we can also go 3-bromo. And finally, we can go 2R, 3S. 3-bromo, 2-butanol. Think that this is a skill that you need to master and to be able to handle for your exam on Wednesday. Let's look at another type of problem with stereochemistry. This time let's look at a simple, can we determine the relationship between a pair of structures? And I've actually given you some more difficult versions of this. So let me give you an easier one this time. So there's one compound. And then with a second compound, since the vertical axis does not change, these are pretty easy to compare. So if we look at the chiral center rendered in yellow, they're the same for both. And if we look at the chiral center rendered in green, these are opposite. So these two compounds must be diastereomers. Again, this is a skill that you want to be comfortable with before you take your exam on Wednesday. Finally, you may have some compounds and you just have to tell me how many chiral centers there are in the compound. For example, let's use this particular compound. Again, from what I said in class the other day, you want to look for ring junctures. So you've got a ring juncture here, and here, and here, and here, and here, and here. This is chiral, and this is chiral. That's 1, 2, 3, 4, 5, 6, 7, 8 chiral centers. So 8 chiral centers. So that we're talking about 512 possible stereoisomers. One question to think about is if you have a chair conformation. And let's say you have a chair conformation where you have one axial and one equatorial. So when this undergoes a ring flip, there's no energetic preference for either one. So each of these will be favored at equilibrium, and these two are going to interconvert into one another. If you were to draw this in a planar structure, this of course is going to be cis, and given the fact that it is cis and there is an internal plane of symmetry, let me draw that a little bit better. It's a meso compound, so we would predict this to be achiral. So you want to watch out for those as well. You also want to watch out for the traditional RNS type configurations. So all in all, on your exam on Wednesday, I see 8 stereochemistry questions. So let me give you a couple to practice with. Let's say that we have I'm going to change this up just a tad. Make this a sulfur atom. Actually, you know what? I'm going to make it a nitrogen atom. That way I can make a double bond. And we have a nitrile as well. So if you look at this closely, should be able to identify 2 chiral carbons. And what I would like you to do is to find out what the configuration is at this carbon, what the configuration is at this carbon. So I think that pretty much sums up all of the different types of stereochemical questions you should be expected to answer, especially when you combine this with the questions that I put on your mock exam. And so I'm going to stop this podcast for now. I would also like to make another podcast that goes through substitution mechanism pretty thoroughly.